Ladies and gentlemen, we're going to go way back in the review machine and do a bonding problem. So we're going to draw a full Lewis structure for this structure here. Label each bond, sigma sp2-sp as an example. And don't forget your pi bonds. And then give both the name of the geometry and bond angles for each central atom. What's a central atom again? One that is bonded to more than one other atom. So H is never central, right? Halogens are almost always never central. And we got some short forms here we're supposed to recognize for functional groups. Far left of the molecule, what's that functional group? If you read it this way, it says CHO. We have to know that's an that's an aldehyde, CHO or OHC. So CHO or dash OHC aldehyde. So copy carbonyl with an H, lone pair, lone pair. So I got that. And then we have a C. What's on this C? N. Parentheses means it's not in the middle of the chain. It's sticking off of the chain from the previous atom. That would be the C right here. And we got a nitrogen with an H and a C. Don't forget, it's a Lewis structure. You can't just draw CH3 every bond. And what about nitrogen? It's not quite finished, is it? Yeah, nitrogen's nature is 3 bonds and 1 lone pair. And then you draw the bond to the next carbon. That's this one here. And it has no bonds to anything else except for the next carbon. Yeah. Back to purple. There it is. And then you got an H. There's another short form. Yeah, CO2R or RO2C is ester. Oh man, did I get that in the way of my molecule? Probably. That's okay. CH is bonded to a carbonyl. I went purple. I'll go green. 2 greens. Why not? 2 greens. Purple's here. I did all the writing for the ester in purple. I'm going to make it purple. Carbonyl, O, and then the C. Each O needs how many lone pairs? 2 lone pairs. And the C has no H's. The next C has no H's. Oh, it does have an H. Now it's time for pi, isn't it? We'll put pi's all in red. What about this carbon here? It doesn't have an octet, does it? How do you fill the octet? Pi bond to the left? Well, what's wrong with that idea? You get an octet violation for 5 bonds to the blue carbon. It's got to be to the right. Hey, how about another one like this? Don't do this. Don't stop. Don't. Octet violation on the black carbon. You better go on the right side. All those carbons are now happy. And then the last 2 carbons in black at the far right, I think you need 2 pi. Overall, the black and the 2 reds is called a triple bond, right? Sigma and 2 pi. And then it's labeling time, right? Oh, what? We want this to be as clear an educational example as possible, right? Let's go new page, do the labeling over here. Nope. You don't know what's continued. It looks the same, right? And we'll put the labels here in orange. We got an A and an A. I think those are the only two A's on here, right? Is A a sigma or a pi? Sigma, it's the only bond. What's the hybridization on a hydrogen? That's a trick question. Hydrogen can't hybridize. So what orbital is the only orbital available? S. What about the carbons attached? The blue one and the green one. sp2. 3 sigmas, no lone. Wow. 3 sigmas, 0 lone pairs. That's 3 fingers. sp2. And let's do the other hydrogens and then move on from there. That's an sp3 nitrogen. That's an sp3 carbon, sp3 carbon, sp3 carbon. And that's the end for B. S is now to sp3. And then C. Misleading, my labels shouldn't have been these because these things here. I don't know. 1, 2, 3. There you go. So we're on part 2. Okay, and C is also S to SP. And now he's going to add question 4. Which bond 1, 2, 3. No, A, B, C, dude. I changed the labels and then I changed them again in my head. Ah. All right. A, B, C is strongest. Explain. Oh no. Anyone want to take a stab? Yeah. She likes A. She likes C. The percent of S in C is 50%. C, because SP is 50% S, therefore closer to the nucleus, therefore stronger. Bonds that are closer to the nucleus, electrons coming in tight, that's stronger. It's good. Hybridization is not just a thing, it explains some chemistry. All right, carrying on with our labeling now. Just go left to right, finish it off, or right to left. Let's go right to left there. D. So D is sigma because it's the first bond. And the hybridization of each carbon is the same, right? What are they? sp-sp. That was a unique bond, and E is a unique bond. There's no other E's here. Yeah, that's the only E in this whole page. Yeah. sp3 oxygen, correct. Sigma, sp3 oxygen. And the carbon in black is sp. Color coding in case you want to review. sp3 for this one, sp for that one. When you count for hybridization, you count sigma bonds and lone pairs. And that has 2 sigma bonds, that oxygen in purple, and 2 lone pairs. That's sp3, 4 things. And then F, I believe there's an F there. Oh, don't change the color now. F and F. SP to SP. Oh, no, that's wrong. Never mind. That's sp3, oxygen to sp. And then we have sp3 nitrogen to sp. And I think that's it for F. Sigma between sp3 and sp2. And then a whole bunch of G. No, not much G. 3. G, G, G. Sigma sp2 to sp2. Once again, why is the oxygen sp2? It's got one sigma, two lone pairs, that's three things, sp2. And G, H and H. Sigma between an sp2 on one of the atoms, and that central one is sp. Sigmas are almost done. I think we're down to 2. We have an sp3, sp2 already? Yes, F. I missed an F, right? No, I need sp2, sp2, which is a G. I missed this G. You guys were eventually going to tell me, right? I missed it. sp2, sp2. And then we're down to this down here. And what are you going to call I? What do you call I? sp3, sp3. Only one of those. What kind of molecules have the most sp3, sp3s in them? Give me some examples. You think of just chains of carbon that are sp3 straight across? Alkanes. How about fatty acids? Isn't the majority of that like saturated fatty acids? Aren't they all sigma sp3, sp3, the carbon? Yeah. Waxes. You know about waxes? We've never talked about waxes. No. Waxes are just esters with a huge hydrocarbon from the carboxylic acid and a huge hydrocarbon from the alcohol. Like more than 40 carbons in there, and you get, you know, a wax, like a hard but a little slippery, right? It's a unique substance. So they have a lot of that sp3, sp3. Our molecule does not. That's weird. That's like for organic chemistry, it's weird to have only one bond like that. Dessert, J. You need a J and a K. Based on Dr. Whitaker's history, you always need at least 2 types of pi bonds. You know that, right? Pi and pi, but they have to be different. So how do you make them different? Oh, she gave me a unicorn. If you have a PY and a PZ, they can't bond because they're not, there's no overlap. Now you need PY, or PX, or PZ. As long as they match, I'm happy. Because those are the ones that overlap. So 3 types of pi are possible. And you need both of them here. One of those red bonds is J and the other one is K, right? And up here, you can just go J. Here you can go J, but you can't go J here. Why would you lose a point if you wrote J there? Just tell me why. That second J is wrong. You've already used the S, the PY in this direction. It's unavailable for any other bond. It's done. So you have to use a new one for K. Pen, K. And you can go J or K over here. I'll go K just for fun. All the pi's are done, and we're done. No, we're not done. We didn't do the geometry, which I don't think we need a new page for that. We'll do geometry part I in pink. That's geometry. So we're just going to do like capital A, capital A, capital A. Any more sp2 carbons around? It's all of them. sp, nope, yeah, I got them all. And B is sp carbon, so that would be B, B, B. And then we'll skip C because it looks like the other C is too much carbons and letter C. And we'll go to D for nitrogen. Do we have an sp3 carbon yet? Don't think so. E. Any more sp3 carbons? No. We got a bent oxygen. Oops, he gave away an answer. And I think it's all the central atoms, right? A, B, C, D, E, F. A, C, D, E, F. All right. What's the, do I want name first? Name and geometry. Good. For A, what's the name of the geometry? Trigonoplanar, because it's SP2. You put your fingers up, right? Trigonoplanar. Trigonoplanar. Whoa. Control Z. Whoa. Clicking on screen. Don't see the A anymore. Sorry. 10. Trig planar. What's your angles for trigonoplanar? 120. What about B? It's SP. SP. You got two sigma bonds to get away from each other. That's linear. And what's your angle for linear? 180. And we don't have a C. Sorry about that. Said I was going to skip it. Forgot. D is, where are you, D? Oh, yeah. It's a nitrogen with 3 sigma bonds and a lone pair. So it's sp3, but it's not tetrahedral. Because that lone pair pushes those bonds down. What do you call it? Pyramidal. And it's sp3. Every angle is always the same for sp3. What is it? 109.5. E is also sp3, but all 4 positions have atoms on them. What do you call that? Tetrahedral. 109.5. And F is also 109.5 because 2 sigma, 2 lone pair. That's sp3. But what do you call it when 2 of the lone pairs are pushing the 2 atoms away? Bent. Now we're officially done. The clock shows us, I don't know what that was. Okay. Big picture. There you go, you got it all. Oh, stop video.